Hello and welcome to day 18 of my 365-day programming journey. Day 17 was a bit of a test with YouTube Shorts, and I will be doing more of those in the future, but today I want to go back to the normal format a bit. Kinda. It's going to be a touch longer than usual, because I want to try to step through the code more thoroughly and sort of explain it in a more natural kind of way. But first, our sources today are this OpenGL tutorial by freeCodeCamp and glfw, which is the library for OpenGL we'll be using today. With that out of the way, let's get to the code. Hello and welcome. This is going to be a little bit different. We're going to be actually stepping through the code in a much more thorough kind of way than I've been previously doing it. It's not going to be scripted. We're just going to walk through it. I'm going to try to explain it, and I want to preface this that I am not proficient in C++. I am explaining in a way that I know it, and it's going to be wrong in a lot of cases, or not a lot of cases, hopefully, but in some cases it's definitely going to be wrong. So don't take this as like a guide on how to write C++, because it's just not. It's just me making a little thing from a tutorial that I followed on how to render a triangle with OpenGL. So of course, like all the projects, we start with these imports, which is, in this, it's hashtag include, which reaches out to these header files in this iostream. So if we click on it, it goes out to whatever all of this is. I genuinely don't know. iostream seems to be a very standard kind of import thing for C++. These first two things are probably the most vague pieces of code in this, because even in the tutorial that I'm following, he doesn't really go over what they are exactly. This is actually him explaining that it's kind of high level, or he explains it in a high level way. As far as I can understand, it's maybe reaching out to some kind of or writing code. I don't know. So if, I need to look into these maybe if I continue with OpenGL, which I might. I really do like it. It was really fun. So first here we have a glfw in it, which is you have to run this before basically anything else, because this is what initialize glfw, and basically nothing else is going to work if you don't have this. So if we like commented this out, it's actually going to throw an error. Yeah, it's I'm not going to go through it doesn't really go through what the exact thing is, because I don't have that debugger open right now, but yeah, so very important. These window hints are basically what it takes for to recognize what version of glfw we're using. I'm not sure how that works exactly, because so in the tutorial you have to build glfw and then move it into your project. So I guess there's like a disparity between what it knows and what the built version does. But yeah, it's 3.3.6. So we have major and minor. So 3.3 and then 0.6 I guess is irrelevant. And there's this OpenGL profile and an OpenGL core profile. So it's just narrowing down further what we intend to use it for. And right here are the vertices for the triangle that we were going to be making. It's basically just points on a grid. So if we're at, if we're at 0, 0 here, negative 0.5 might be here, 0.5, negative 0.5 is going to be, well, actually it's going to be right here, and then up here, right? So I got my triangle wrong, but yeah. So this is the top point, this is the right point, and this is the left point. Down here we're actually creating our window. This is just the the actual, instead of using a console, we'll be using a window like we use most other applications with for the GUI. And check if the window is null, and if it is, we're going to go ahead and terminate and return out -1, which is what happened when I ran it without the initializer. Make context current, that's just this like thing where, so if I click here, this is in the current context current, I believe that's what reaches out to like the actual Windows operating system and tells it, or the operating system, because this is multi-platform, and tells it to be the window that you're focusing on. And then glad, don't know what I genuinely don't know what glad is. I'm not sure what the importance of it is. GL viewport, I think that's just getting the viewport set up, maybe, for OpenGL. So it takes the window and it does something with it. Who knows? We can actually look it up. So since we're taking a lot more time with this, we can slow down and look at what stuff is in the documentation. So if we copy that and we go way up here and we search it, so GL viewport doesn't have any matches. Awesome. I don't know what to make of that. Hold on, maybe I searched it wrong. Viewport. That's unfortunate. Well, I guess we won't be learning about that right now. GLU unsigned integer, which is just it's a specific like GL thing, or like for GLFW, so it isn't, I guess it's a more like multi-platform support. So here we're getting our shader, vertex shader. So create shader, and it's creating a fragment shader. So vertex shader is like the line out, I believe, so it can determine like what points connect to what, and then fragment shader is what actually colors it in. Shader program, this is what I keep saying actually, this is what uses these defined shaders to determine what it prints out to the screen, I suppose. And then we're done with these shaders because we've already attached them to the shader program, and we just, with C++, you have to dereference things and get rid of stale variables and whatnot. So I assume that's just, garbage collection. Then we have another GL unsigned integer with this vertex array object. It says it down here, and then this is vertex buffer object, I believe. So yeah, so basically a buffer is like, it's a set of data that isn't being used yet, but is going to be pushed into like the display or something like that. So you have one frame that's being rendered. So this is what you're seeing, and then while you're seeing this on frame 0, frame 1 is getting prepared in the buffer. So you like maybe draw something else on it, so it's a little bit different, and then it will, on frame 1, it'll show this. Like realistically, you wouldn't be able to even see frame 0 with the human eye, but that's just basically how the frame buffer works. I mean, you would see it, but like if it changes this drastically, it's going to be kind of hard to notice. Let's keep this open actually. Oh gosh. Okay. And then you have to bind them as well, which I think that just you know what? Right here, let's look it up. Let's look up what it does, because that's this is a learning kind of experience video. This is very different than all the other ones where I have a semblance of knowing what I'm talking about. Here, let's Google search this. So I actually want to find out. Binds the vertex array object with the name array. The array previously returned from the call. 0. No vertex array exists. Yeah, okay, so that's not super helpful, I don't think. Still don't know what binding does. It seems like binding is a whole concept of its own. I'll have to look into that, later on. Maybe I can make a video on binding. I don't know. Get the vertex. A lot of this I'm very unknowledgeable about. This is very specific to OpenGL and way out of my forte. Again, I was just following a tutorial and I'm trying to explain it so I can help myself learn. And this is, the true meaning of the 365-day journey is learning more about programming. So this I do know. This I get a little bit. I realize this is a vector 4. So we have x, y, z, or x, y, x, y, z, and alpha, or x, y, z, however you want to say it. And this is clearing the color, which, as far as I understand, it's required to do it here as well as every frame. So this is a while loop. So this is happening every frame that it can render out to. So it has to be cleared out. So I guess it's just clearing out the buffer so it's prepared for the next frame, and then we'll swap the buffer or swap buffers for Windows so it has the ready one, I suppose, for the next frame. So again, here we're clearing it out using the shader program to render it, and then binding it, and then drawing it. So I guess this is the actual part where it draws it out, and it uses this primitive shape defined by the GL library. And then it swaps the buffers back out, and then pull events, which is what actually executes all of this to the screen. So it's like, so it actually runs all of these instructions. And once we're out of the loop, which there's nothing really calling this in a sense that, like, if this was just a variable where I like bool is game over, like I did in the Tetris thing, I don't think that'd be as inclusive or as expansive of checks as this is, because I think this is checking for a whole bunch of other things. Or maybe it's not. Maybe it's just waiting for a key press or you know, waiting for me to define what should close it. But it is it's an easy built-in function to check if the window should still be open. And once it's not open, you know, when we're out of this while loop, we need to go ahead and delete our vertex array, the buffers, and the whole shader program, because again, C++, you don't want to have loose references. But I'm not sure if that's super important at this step, because you're just going to return out anyways, and all this is going to be deleted anyways. I could be wrong about that. Maybe there is some reason why you would want to do this at the end of the program anyways. I guess it's just safer, because otherwise, you know, if you forget about it or forget that these are a thing, and you have a different function down here that doesn't even require this stuff, you're just wasting memory at that point. So yeah, that's a little triangle program. So let's go ahead and run it and see what we can get. So first triangle, of course, is just this little oh, what is it called when they're all like equal degrees? Isosceles, I think. I should have paid attention more in school. So there's that triangle, but we can, you know, knowing what we know about the vertices here, we can actually, so this is, you know, 0, and this is 1, 5, so that's obviously the top point. So we can actually change this to a 1, and boom. We got one that extends actually past the top of the screen, which is a little interesting. Huh. So it's supposed to be a value between 0 and 1, but I guess the 1 isn't, it's not like a perfect thing. So let's try, yeah, let's set this to 1, set this to like 7, 5, get a real crazy triangle going on here. And we could probably, like, if we go back, I wonder if we can like shift the entire thing over. Oops. So let's go back up here. So -5, let's change that to 6, 5, 6, 5, 6, 5, 6, 5, 6, 5, and 0.15, because we're shifting it all over by 15 degrees, or 15 units. Okay, that didn't work. Maybe it doesn't work how I thought it did. So 15, 6, 5, oh, duh. This needs to be, so, oops, so 5, 4, 35, duh. Math, am I right? So that's over, it's over a little bit. That's over quite a bit. Sure, let's just run that, see what happens. Yeah, so we shifted it over a little bit. I'm sure my numbers are still a little bit wrong, but yeah. But yeah, that's the little program that I wrote today following freeCodeCamp's video on making a OpenGL triangle, basically. I know this was a more awkward kind of video than the other ones are, and it was a lot less professional, but it was a lot more fun and, you know, more real, I guess. Please don't make fun of my programming knowledge. And that's about it. That wraps up day 18. Thank you so much for watching. I hope you had a great Tuesday. Yeah, because, yeah, Tuesday. And I'll see you tomorrow.